Open your book to page 358. Today's lesson is on vectors. And so let's go over some of the terms. So look in your book. Notice all the blue phrases or words are important. So first one is a scalar quantity. Scalar quantities means that only the length matter or the number matter. It doesn't matter the direction. So for example, like area, volume, those don't have directions. Then in contrast with that is the vectors. Okay, the vector quantities, vectors have the direction and the length. Okay. And so when you draw the picture, okay, so if you notice over here in this picture, the figure 1, so if you go down a little bit, so if you look at this picture over here, so this is the vector. Vector is like an array, right? So this, the point that you begin is called the initial point. So initial point is where you start, and this is your terminal point. This is where you end. And notice at the end it has a little arrow over here. And that's how you write a vector. So this is the vector. Vector is equal to from A to B. And notice the little symbol over there. So just be familiar with it. So again, initial point is where you start. Terminal point is where you stop. Okay. And let's go to page 359. So over here, the magnitude is the length of the vector. And same direction. The vectors are in same direction if they have the same starting point and they point the same way. Opposite direction means they are parallel, but it's going opposite direction. Zero vector means just a dot. Okay, you have the length of 0, and the direction is any direction when you have a dot. That's what a zero vector is. Equal, so two vectors are equal if they have the same direction and the same length. Okay. And translate, that means a vector can be slided all over the place as long as you keep the same direction and the same length. So for example, like if this is the vector, you're allowed to slide it. You can allow to slide it any way you want, as long as you keep the same length and point the same direction. So the vector you can move it over any way you want, as long as you keep pointing the same direction. But if you change direction, then it's no longer the same vector. Now, when you add the vectors, there are two methods. When you're adding two vectors, one method is called the tail to tip rule. The other one is called the parallelogram rule. Okay, so let's go ahead and look at what does that mean. Okay. So let's say if you have one vector here and you have one vector here. So to add, all you have to just put this, so tail to tip. So in other words, you just go and you just continue to add it on. So you just do it this way and then you add it on. So your result is this. So if this is a vector A and this is a vector B, so that's your vector A, that's your vector B. So your result would be here. So this would be vector A plus B. Okay. So this is called so this is the tail to tip. So here's the tip, here's the tail. So tail to tip. So you just continue on. That's one method. Another method is called the parallelogram method. The parallelogram method is you put these two together. So you have this over here and you put this right over here. So this is your A and this is your B. And what you do is you draw a parallelogram based on that. So draw a parallelogram. So you slide this over. So this is like A, and you slide this over. So this is your B, and then you draw the diagonal. So this is called the parallelogram method. But either way, both methods should be the same. Okay? So that's how you add vector when you're doing the graphing. So now let's go over some examples of how these things work. So let's go to page 364, and let's just go and do some examples. So let's go and do number 2. Okay, number 2, by the way, the absolute value means length. So what it's saying is that length of U is equal to 65 km kilometers per hour. And the length of V, or absolute value of V, is equal to 17 kilometers per hour. And what they want you to do, they want you to find the absolute value of U plus V. Okay, so first you need to find absolute value of U plus V. And notice over here, and theta, and they give you the picture. So what you want to do is just use a Pythagorean theorem. Again, if you look at the picture, so it doesn't matter which method you use. So if you use the method B, okay, so notice here's your U and here's the V, right? So here's the U, here's the V, and here's the U plus V. So to find the length of that, you use Pythagorean theorem. So you're going to square root of 65 squared plus 17 squared, right? So that's what you're doing. Again, you're looking for length. So you're just using Pythagorean theorem. And so that's going to get calculator, and that's going to multiply out. So 65 squared plus 17 squared, push equal, and you take the square root, and it comes out to be 67.2 kilometers per hour. Okay, and that's it. Okay. So that's the length of U plus V. Okay. And the next part, they want you to find theta. So they want you to find this angle. So this one you have to use, you need to use a trigonometry, right? So to find theta, so you get tangent theta equal to the length of V over length of U, right? Again, absolute value means length. So tangent theta equal to 17 over 65. So you can get theta equal to, let's do step by step. So tangent theta equal to, so 17, let's just go and do directly already. Because you're using calculator anyway, right? So just go 17 over 65, and you go second tangent, and that will give you 14.66 degrees. Okay, and that's it. So you can very simple, just think of it as like your right triangle. Okay. Now let's go to number 8. So on page 365, number 8, you have the length of V equal to 72 pounds and theta equal to 68 degrees. And you're looking for the H and the V. Okay, so you're looking for horizontal and vertical. Now notice, you have to pay close attention now. Okay, notice it's a capital V versus a small v. So this is a small v. This is the small v stands for the vector, and the absolute value, this means the length of the vector v. Whereas the capital V stands for the vertical length. Okay? So you can make sure you kind of understand all these terminologies. Okay? And so here's theta. So what you're looking for is, so this right over here, that is the capital V, the big V, the vertical. And the horizontal is right over here. So that is the horizontal. Again, absolute value means the length. So this means the length of the horizontal. This means the length of the vertical. That's what it means. Okay. So again, once you understand what those means, it's not that difficult. Okay. So what you want to do is you just go and use your trigonometry, right? So this one is 72, and this is equal to 68. So this is sine, right? So sine of 68 degrees is equal to the big V over the small v, the 72, right? So this is the, right? So you can just go and use your calculator to work it out. So the big vertical length equal to, so you go and multiply, this can come out to here, right? So 72 times 68 sine, push equal. So this is equal to 60. If you run it off to 67, that's fine, but it has a label, right? Okay. Now let's go and figure out the horizontal. Horizontal is cosine, right? So you get cosine of 68 degrees equal to the horizontal over hypotenuse over 72. Right? Again, just very basic trigonometry. Again, move this over here. So your horizontal equal to, get the calculator, punching all the numbers. It comes out to be about 27 pounds. And remember the label, okay, because what you're using this for is for like physics. So the pound is the force. And that's how you do this kind of problem. Okay. Now, when you get to like number 14, now notice these are right triangle. So you can use sine, cosine, tangent, right? Now, when you get to like number 13 through 16, those are not right triangle anymore. So that means you have to use what? You have to use law of sine, law of cosine, right? So just be aware of that. Okay. And now let's go to number 18. Let's go and read the instruction. It says, determine whether the vector A, B, and C D have the same direction, opposite direction, or neither. Okay, so number 18. So point A is 3, 2. B is 3, 7. And C is 1, negative 1. And D is 1, negative 9. Okay? So you want to, so this is the beginning, this is the end. So to figure out the direction, what you need to do is you just go and find a slope. Right? Slope and direction are the same. And the way to do this is, the way to write vector is using, this is called a caret. Okay? So from 3 to 3 is 0. Okay? So you just use the end minus beginning. So 3 minus 3 give you 0. 7 minus 2 will give you 5. So the direction of this means you go 0 in the x direction and you go up 5, right? So 0 means nothing. So it means, so if you're going to draw the vector, this will go straight up and down. So again, this is the how much you go in the x direction, how much you go in the y direction. So this will give you the slope. So in this case, the slope would be 5 over 0. Okay, again, this is your y2 minus y1. Okay, so again, remember the slope equal to y2 minus y1 over x2 minus x1. So this is that. So in this case, you can see the slope from here. So in this case, if you want to see the slope equal to 5 over 0, or it's undefined. Okay. Now over here, so 1 minus 1 give you 0. Negative 9 minus negative 1 will give you negative 8. So do they have the same slope? No, right? Well, actually they do. So slope equal to negative 8 over 0. So again, it's undefined. So actually both have the same slope. So to answer the question, whether they have the same direction, the answer is yes. Okay? Well, take that back. This is negative. So actually they are negative. So they're opposite direction. Even the both are infinity. So this one is going up. This one is negative. So it's going down. So these have opposite direction. Okay? So you have to figure if they're same, opposite, or neither. So let's go and do another one. Let's go and do number 20. Okay, so number 20, the point A is 6, 3. B is negative 2, 11. And C is 2, 7. And D is 9, 0. So again, let's go and figure out the vector. So negative 2 minus 6 will give you negative 8. 11 minus 3 will give you 8. So again, I just do all this extra just to show you what all this means. Okay? So if you want to figure out the slope, you don't have to, but to figure out the slope will be equal to 8 over negative 8, which is equal to negative 1. That's what that is. Okay? Just so just to show you the relationship between the slope and the vector. So this one over here, the vector would be 9 minus 2 will give you 7, and 0 minus 7 will give you negative 7. So the slope will equal to -7/7. So slope equal to -1. So these two will be parallel. So in this case, they will be same direction. So in this case, both will go in the same direction. So again, if the slope, this is positive, this is negative, and both are undefined, so both this is opposite direction, this will be same direction. Now if it's neither, then the answer is neither. Okay, so let's go and do some practice.